Hi. In this video, we are going to look at a problem on straight lines. So let's get into it. A straight line through the origin 0, 0 cuts the lines x is equal to alpha, y is equal to beta, and x plus y equals 8 at A, B, C respectively, such that OA into OB into OC is equal to 48 times root 2, and f of alpha comma beta is less than equal to 0, where f of xy is equal to mod of y by x minus 3 by 2 plus 3x minus 2y power 6 plus square root of e power x plus 2y minus e square minus 6. Now, this information is given, and then there are some options. Option 1 is OA plus OB plus OC times 2 root 2 is equal to 36. Option 2 is OA times OB plus OB times OC plus OC times OA is equal to 39. Option 3 is 25 times alpha is equal to 50. And option 4 is 18 times beta is equal to 27. So the question looks a little weird. There is a straight line that cuts three given lines where alpha, beta are unknown at 3 points A, B, and C, such that OA, OB, OC product is given. So as soon as you see this, notice that OA is the distance of A from the origin, OB is the distance of B from the origin, and OC is the distance of C from the origin. So you should immediately think of, they are giving us the length, three distances, and the product is given. So this should remind you of parametric form of the line equation, because you can say that this distance is R1. So any line through the origin can be given by x minus 0 by cos theta is equal to y minus 0 by sine theta is equal to r. So any point on the line can be given by r cos theta comma r sine theta, right? Obviously, here r will be different for these points. For point A, it might be r1 cos theta and r1 sine theta. For point B, it might be r2 cos theta and r2 sine theta. And point C might be r3 cos theta and r3 sine theta, right? So we will get to that. And this simply OA, OB, OC here is simply R1, R2, R3, the product of the distances from the origin, right? The reason we are using parametric form is that it reduces the number of variables for us by a lot. If I had taken three arbitrary points, A, B, and C, and in Cartesian form, I would have to think about two variables for each of them, right? You would have alpha comma y coordinate for A, similarly x coordinate for B and beta, and similarly xc comma yc. So there are many variables if you take normal Cartesian form, but if you take parametric form, the only variable is r, r1, r2, r3, the distances from the origin, and theta, which is the slope of the line, right? Okay, but before we go ahead here, we have to figure out why they have given us a complicated looking equation of f of xy, right? So the question has said that f of alpha beta should be less than equal to 0. But if you look at this function closely, you will realize that all the three parts of the function are always positive. There is a modulus which will always be positive. There is something to the power 6 which cannot be negative. Similarly, there is a square root and this will always be positive. So how can f of xy be less than equal to 0 if each part of it is positive, right? The only way in which this inequality is satisfied is if f of alpha beta is equal to 0. That's the only condition where it is possible that f of alpha beta is less than equal to 0. And if f of alpha beta is equal to 0, then each of these things must individually be equal to 0, right? Why is each of them have to be 0? Because if any one of them is positive, then your overall answer will be positive because none of them can be negative. So all three of them have to be 0, which will immediately give us the value of alpha beta. So let's do that here. So f alpha beta is equal to 0 implies we have beta by alpha minus 3 by 2 modulus plus 2 alpha, no, 3 alpha minus 2 beta, 3 alpha minus 2 beta whole power 6 plus root over e power alpha plus 2 beta minus e square minus 6 is equal to 0. So if each of these terms are 0, from here we are getting beta by alpha is 3 by 2. This is also going to give us the same thing. Beta by alpha is 3 by 2. And now here I need to make this part 0. So I have to have e power alpha plus 2 beta is equal to e square plus 6, right? The obvious thing to see here is alpha can be 2 and beta can be 3. That directly fits the condition, right? So looking at this function, immediately you should be able to figure out the values of alpha as 2 and beta as 3. And therefore 25 alpha is 50, but 18 beta is actually 54 and not 27. So your option C is correct, option D is incorrect. So that is already done, right? And now that we have alpha beta, I can do the other parts of the problem because the question said that the line from the origin O, which is 0, 0, cuts x is equal to alpha. X is equal to alpha at A, right? Now, alpha we have gotten has come out to be 2 and beta was 3, right? So basically this point will be 2 comma something, right? X is equal to 2 line. And now we will write it in parametric form. So we'll say any point on this line can be written as r1 cos theta comma r1 sin theta. So that should be same as 2 comma y coordinate. So basically from the first part of it, we can say r1 is equal to 2 by cos theta, right? Once we get r1 is equal to 2 by cos theta, that's all I need for now because I needed OA. This is my OA distance, right? Similarly, it also cuts the line y is equal to beta. So y is equal to beta. So beta is equal to 3 actually. So you also have r2 cos theta comma r2 sin theta should be the same as some x coordinate and comma 3, right? This is my point B, by the way. So from here I will get r2 sin theta is equal to 3. So r2 will be equal to 3 by sin theta, right? Notice that cos theta and sin theta are same or are constant for the line because it's a straight line and the slope will remain the same. So both of the parametric forms will have the same theta. So I have gotten R1 and R2. R2 is OB, R1 is 2 by cos theta and R2 is 3 by sin theta, right? Now I will try to figure out the third point, which is C, which is where the line cuts the, the other line x plus y equals 8, right? So if x plus y is equal to 8 is being intersected by a random point, we can say r cos theta plus r sin theta is equal to 8. So r should be 8 by cos theta plus sin theta. And this r we will call r3. R3 is 8 by cos theta plus sin theta. So finally what I have gotten is OA, which is R1, is equal to 2 by cos theta. OB, which is R2, is equal to 3 by sin theta. And OC is equal to 8 by sin theta plus cos theta. And that is my R3, right? Now, the question also gave us the information that R1, R2, R3, which is basically OA times OB times OC, is equal to 48 root 2, right? So this is equal to 48 root 2, and we'll try to solve this to find our theta. So what we get here is 2 by cos theta times 3 by sin theta times 8 by sin theta plus cos theta is equal to 48 root 2. You can see that 48 cancels completely, and we have the relation 1 by root 2 is equal to sin theta cos theta times sin theta plus cos theta. So if we can solve this equation, we will be able to find out our theta, right? The way to solve this trigonometric equation will be using a substitution sin theta plus cos theta is equal to t, because if you square it, you will get 1 plus 2 sin theta cos theta is equal to t square, and therefore sin theta cos theta can be written as t square minus 1 by 2, right? So this equation becomes 1 by root 2 is equal to t square minus 1 by 2 times t, right? And now what we will do is cancel this, and this becomes a root 2 here. We'll square it, and we get the equation 2 is equal to t square minus 1 whole square into t square, right? You can try to simplify it and solve it, but you can see obviously from here, t is equal to root 2 is the solution. If you do t is equal to root 2 or t square is equal to 2, you'll get 2 and 2 minus 1 whole square. So that is same, right? So t is equal to root 2 becomes a solution, which means sine theta plus cos theta is equal to root 2. And from here, I can write this as root 2 sine of theta plus pi by 4 is equal to root 2, which implies theta is pi by 4. So once I get theta as pi by 4, I can find each of the R1, R2, and R3. I will get R1 is equal to 2 root 2, R2 is equal to 3 root 2, and R3 is equal to 8 by root 2. So it is going to be 4 root 2, right? So R1, R2, R3 have come for us. And now I can check the other two options, option A and option B. So option A was R1 plus R2 plus R3 times 2 root 2. So that will become 5 plus 4, 9. 9 root 2 into 2 root 2. So that is clearly 18 into 2, 36, right? So what we have gotten is R1 plus R2 plus R3 into 2 root 2 is equal to 9 root 2 into 2 root 2 is equal to 36. So option A is correct. And similarly, option B is R1 R2 plus R2 R3 plus R3 R1. So that was 2, 3, and 4 root 2s, right? So 2 into 3 into 2 plus this would be 3 into 4 into 2 plus this would be 4 into 2 into 2. So this becomes 12, this becomes 24, and this becomes 16. So actually you are getting 52 here and not 39, right? So the correct answers for us are A and C in this problem. The problem is not difficult if you do parametric form of straight line. If you do any other form of straight line, you might get too many variables and get confused. Why should we get the idea that this problem involves parametric form? The idea comes because they have given us an expression where they have given us OA into OB into OC, right? They gave this and they said that the line passes through the origin. This would be the distance of the 3 points on the line, no? A, B, C. If they are giving us the product of the distances, obviously they want you to use parametric form, right? So that is something that you need to take the hint, and also you need to not get scared by the complicated looking function. There we use the property that the function has 3 parts which are always positive. So the overall function can never be less than 0. If the overall function was less than 0, if that is impossible, the only possibility would be the overall function is equal to 0, which means each part is 0, which gives us alpha and beta directly, right? So that finishes off this problem. And it's a nice question which uses a little bit of functions, a little bit of straight lines, parametric form, and basically tests whether you can approach a problem with an open mind or not. If you get scared by looking at the problem, you can't do it. But actually, the question was not very difficult, right? So you need to not be scared and try the problem and see what is the most appropriate tool, right? So hopefully you'll learn something from this video. I'll see you next time.